This is chapter 12.2, using a point to evaluate trigonometric function notes. You're going to do these initially on your own. I'll do the first one with you, but then you're going to do number 2 and 3 on your own. So I want to make sure that you know how to go about doing this. So the first thing that you're going to do is use the given point on the terminal side of an angle theta, that little symbol right here is called theta. It's actually the acute angle of a trigonometric function. So use the given point on the terminal side of an angle theta in standard position to evaluate sine, cosine, and tangent functions of theta. Now, as you well know, there's a lot of vocabulary associated with chapter 12, so we're going to just continue to review it. Here's your initial side. You want a terminal side, and that terminal side is going to be at the ordered pair -4, 3. So -4, 3, which puts you in quadrant 2. And just for practice, you can see that I've had you label all the quadrants. It just helps you commit this to memory. The only one we really need to focus on is going to be quadrant 2, because this is going to be our -4, 3. And you're going to draw a line through that point. And you'll use a straight edge, which will make it nicer. So this is the terminal side. Now, the vertex is always going to be the origin, or 0, 0. The arc of the angle comes from the initial side to the terminal side. So you can see the arc. You can see that this is in quadrant 2. Here's 90 degrees, 180 degrees, 270 degrees, 360 degrees. You started here first initially at 0 degrees. All right, so your angle for -4, 3 in quadrant 2 is between 90 degrees and 180 degrees. And it is in quadrant 2. All right, now we're going to be finding the sine, the cosine, and the tangent. In order to do that, we have to make a right triangle. This is right triangle trigonometry. You come from the -4, 3, and you draw a perpendicular line to the x-axis. Again, you connect it to the x-axis. There's your right angle. Here is theta. Here's your origin. So there's theta. Directly across from theta is your opposite side. Next to theta is your adjacent side. And across from your right angle is your hypotenuse. Well, your opposite and your adjacent tie into the ordered pair. So opposite is always your y coordinate, so y equals 3. Your y axis, your y value, your y coordinate goes up and down. Your adjacent ties into your x value, so x equals -4. All right, now we don't know the hypotenuse, we need to find that. And in order to do that, we would use the Pythagorean theorem, a squared plus b squared equals c squared, because it's right triangle trigonometry. It doesn't really matter what you make a and what you make b, so it's going to be -4 squared, make sure the -4 is in parentheses, plus 3 squared equals c squared. -4 squared is 16 plus 9, 3 squared is c squared, and then 25 is 16 and 9 equals c squared. The inverse operation for a square is the square root, so you take the square root of both sides. Square root of c squared is c, square root of 25 is 5. Now please note, your hypotenuse is not always an integer value. When you have radical signs involved, you will have to rationalize the denominator, and there are quite a few recordings in chapter 12 to help you rationalize the denominator. So there's one in 12.1 and then another 12.2 that'll help you with that. All right, so our hypotenuse is 5. We know it's always positive. So sine is SOH, S-O-H. The sine of theta equals opposite over hypotenuse. The opposite is 3 over the hypotenuse of 5. Here's your solution. Don't change it to a decimal. If it is a ratio that's not been simplified, though, you need to do that. Cosine is cos, C-A-H, so cosine equals adjacent over hypotenuse. The adjacent side is -4. And the hypotenuse is 5, so -4 over 5. Tangent is going to be opposite over adjacent. TOA is what the memory device is. TOA, opposite over adjacent. Opposite is 3. Adjacent is -4. Now we typically don't write it with the negative in the denominator, so it would be out in front, -3 over 4. If you do, leave it like that, though, it's fine. Okay, you're going to have 2 problems after this, and you'll do those as homework. I'll be checking that you've done them, and then we'll go over them so you have those notes completely taken.